In semiconductor manufacturing, innovation moves fast, but so do the risks. From hazardous chemicals to high-voltage systems, these environments require a level of safety planning that goes far beyond traditional industrial settings. In this video, we're breaking down the key risks, mitigation strategies, and industrial hygiene practices that define a strong semiconductor health and safety program. Semiconductor fabrication involves complex processes that rely on hazardous chemicals, high-energy systems, and precision equipment. As a result, risks span multiple categories, including chemical and gas exposure, electrical hazards, fire and explosion risks, ergonomic strain, radiation exposure, inert gas asphyxiation, and equipment-related hazards. These risks don't exist in isolation, they often overlap, which means safety strategies must be integrated across the entire system, not just individual hazards. Let's take a closer look at some of the most critical hazards. Chemical and gas hazards involve toxic and reactive substances like arsine and hydrofluoric acid, which can cause severe injury or fatality if not controlled. Electrical risks come from high-voltage systems, where arc flash and shock hazards require strict lockout-tagout procedures and compliance with standards like NFPA 70E. Fire and explosion hazards are driven by flammable and pyrophoric materials, making gas detection systems and interlocks essential. You also have ergonomic risks, especially during maintenance and material handling, and radiation exposure from both ionizing and non-ionizing sources. Finally, inert gases like nitrogen can silently displace oxygen, creating life-threatening conditions without warning. Managing these risks requires a layered approach. First, engineering controls like ventilation systems, equipment enclosures, and gas detection are a primary line of defense. Then, administrative controls, including standard operating procedures, training programs, and management of change processes, ensure consistency and compliance. And finally, personal protective equipment such as chemical-resistant suits, respirators, and arc-rated gear provides an additional layer of protection. All of this should follow the hierarchy of controls, prioritizing elimination and engineering solutions before relying on PPE. Strong safety programs are what bring everything together. Equipment Safety Sign-Off, or ESSO, ensures that new or modified equipment is safe before it enters operation. Hazard analysis tools like JHA, HAZOP, and FMEA help identify risks throughout the equipment lifecycle. And Management of Change, or MOC, ensures that any modification is evaluated for safety impact before implementation. Even routine maintenance activities require strict control since they often involve exposure to energized systems and hazardous materials. Monitoring systems play a critical role in maintaining safe conditions. This includes air sampling and gas detection, biological and medical monitoring, noise monitoring, and quantitative and qualitative assessments. At the same time, ventilation systems are essential. From HVAC systems maintaining clean room conditions to process exhaust capturing hazardous byproducts, ventilation is a cornerstone of both safety and process integrity. Beyond systems and procedures, safety culture is what sustains long-term success. This means encouraging hazard reporting, conducting regular audits, maintaining accurate records, and continuously improving training and protocols. A strong safety culture ensures that safety isn't reactive, it's built into daily operations. Semiconductor health and safety is complex, but it doesn't have to be unmanageable. With the right combination of hazard identification, layered controls, monitoring systems, and a strong safety culture, organizations can protect their workforce while maintaining high-performance operations. If you're designing equipment, preparing for compliance, or improving an existing process, these principles are essential. If you found this helpful, Make sure to subscribe for more insight on product safety, compliance, and certification, and visit High Tech Design Safety for more in-depth resources.